Hello, welcome back. Here is Ali Talibi, and this is our second lesson from Module 14. We're talking about different measurements you can use to measure your performance. So we talk about Sharp ratio, trainer ratio, and also I introduce you to Jensen's alpha. In this lesson, I'm going to talk more about the Jensen's alpha, and also I will introduce the information ratio. And we'll wrap up by looking at the different measures and we'll compare them. So let's start our session. So we learned that the alpha is actually the difference between your actual return and what the CAPM is estimating. Maybe that's kind of vague and not clear. You want to have a kind of more clear, more straightforward way of finding the alpha. So another way to calculate or measure alpha is using the regression model. I'm just going to show you how you can actually estimate alpha using the regression. So when it comes to regression, for sure you know that you need to have two variables, independent variable and dependent variable. And our goal here is to know whether the returns of any investment are consistently higher or lower than the market by the fixed amount. So what we do, we define our independent variable or X as market risk premium. What is the market risk premium? Yes, expected return on the market minus the risk-free rate. And we define the dependent variable as the risk premium for the security or an investment or portfolio, which is ERI minus RF. Now, based on this, you can run a regression model and you can find the slope and the intercept of this model. And the intercept of this model will be actually the number we're looking for. That's the alpha. It's showing the difference between the actual return of your investment and what the CAPM is estimating. I'm going to provide you an example to show you how actually it works. Now, let's assume you're talking about the last 10 years and you have information from the security or the investment and also the market. So the first step here is to find the risk premiums for the security and market. So to explain this concept, so let's look at the Excel file I prepared for this. Let me walk you through the steps you need to follow to estimate the alpha. Okay, here is the Excel file I mentioned. Here are the information. So you have information regarding the year, the market returns and the security returns as you see here, and also the risk-free rate for these 10 years. So the first step, as I mentioned, is to calculate the risk premiums. So we know the security risk premium, that's the return for the security minus the minus the risk-free rate. So 12% minus 2%, it should give you 10%. The same argument is for the market risk premium. However, here we use the market return. So that's a market return minus the risk-free rate. It gives you the market risk premiums. So what we need to do, we need to do the same thing for all 10 years. So I'm just calculating, I'm using the Excel file to calculate actually the risk premiums for security and the market. So if you look at all these numbers showing the difference between the security returns and the risk-free rate, same for the market risk premium, which is the difference between the market return and the risk-free rate. Now, I mentioned the alpha is actually the intercept of the regression model you are here running. So I have to run a regression. So I go to data and data analysis. If you don't have that add-on, data analysis for free, you can download and add to your Excel the data analysis tools pack, actual tool pack. So I hit on data analysis and I go to regression. So let me just bring the regression. So here is the regression. I open the regression tab. So what is your Y range? Your Y range here is your Y, as I mentioned, that's your dependent variable. So your dependent variable here is the security risk premium. Security risk premium, that's your dependent variable. What is your independent variable or X, which is the market risk premium? I chose that range as well. I don't need to change any other setting, just I'm going to specify the output. So let's ask the Excel to provide the output in one of the cells here. So, and then I hit OK. Now you have the very nice summary output with information of the ANOVA and the slope and the intercept. So which parts are kind of important for us? One is the kind of the R square, which is showing what percentage of the actual independent variable is explained by your dependent variable. What percentage of Y is explained by X? So almost 21%, over 21%, which is a pretty good number. Anyway, when you go to intercept and the coefficient, this actually part is showing the coefficient and the intercept. As I mentioned, we are more concerned about the alpha, which is your intercept. So here is the part which I need to focus on. So what does it mean? It means my investment in this case is providing 2.3%. So here is 0.023. In terms of percentage is 2.3%. So it is providing 2.3% over what the model is estimating. That's my alpha. This is showing how well I'm performing as a money manager. So here it's your alpha. I'm just putting this as alpha. And in terms of the percentage, I can change it to the percentage. Make sure that we have the percentage number here, which is a pretty good number. Now let's go back to the rest of presentation. Now let's assume as a manager you report a positive alpha. So you're saying that the alpha is positive for the portfolio or the investment. Now the question here is that maybe that's a one-time positive alpha, or maybe the alpha that it is reported is not significant. It's not statistically significant. It's not actually consistent in terms of the performance. How you can make sure that the reported alpha is reliable? So that's a question you can answer by looking at the information ratio. So information ratio actually is helping us to capture the effect of both alpha and the tracking error. And what is the tracking error? Tracking error actually is measuring the volatility of the fund's return related to the market return. In other words, it actually shows the standard deviation of the errors. Now, if these errors are too big or too much, the information ratio becomes smaller. So the reported alpha is not reliable. So if you just look at the alpha, it's misleading because it ignores the errors or the tracking error or the standard deviation of the errors. So you have to look at the information ratio. And for sure, another way here is just to look at the significance level of the alpha using the regression model. So as we explained, the alpha using the regression model, you see that the Excel is also providing you the p-value for each variable, including the intercept. So you can use that to see whether the reported alpha is significant. Another way is using the information ratio. For the same example, let's look at the Excel file and calculate the information ratio, and also we'll look at the regression model just to make sure that we are looking at the significance of the alpha. So let's talk about the information ratio. So we already calculated the alpha, and I explained how you can find the alpha using the regression model. That's a regression output of our calculation. Now let's talk about the information ratio. As I mentioned, there are two ways you can actually look at the significance of the alpha. One is looking at the information ratio. So let's talk about this first. How we can calculate the information ratio? That's the alpha divided by a standard deviation of errors. How we calculate the errors? So let's look at the errors first. So that's the difference between what actually risk premium you are getting from the market and what you are getting from the security. So if you deduct or subtract the market risk premium from the security risk premium, you will get the error term for each year. So I'm doing the same thing for 10 years to find the error term. And then I will use the built-in function in Excel to calculate the standard deviation of this sample. And this is the sample, that's why I'm using the standard deviation for the sample. It is just for 10 years. You don't have information for the whole population. Now I just found the standard deviation of the errors. If I divide the alpha by a standard deviation of errors, I can find the information ratio. So that's alpha divided by a standard deviation of the errors. So which gives me 0.22 almost. That's my information ratio. Again, we prefer to have higher information ratio, which means lower standard deviation of errors and higher alpha. So when you have different investment, when you have different type of portfolios, you prefer to have higher information ratio, which means the alpha is higher, the errors is lower. So the information ratio in that aspect, maybe it's not very reliable to look at one individual investment. When it comes to comparison, actually it works very well, and it is very useful. Another way, as I mentioned, is looking at the regression model. We already talked about this regression model, and I mentioned the alpha is your intercept. Now, the question here is how significant is your alpha? Now, you can look at either the t-stat or the p-value. You prefer to have higher t-stat or lower p-value. If your p-value is less than 5%, you can say that actually your alpha is significant. If it's greater than 5%, your alpha is not reliable. In our case, the p-value is almost 0.5, which is much greater than 5%. So in other words, we can say the reported alpha 2.3% is not very reliable. Maybe that's one thing phenomenon that just happened once, so you cannot rely on that. So you are not significantly different from zero, you can say that. So the alpha is not reliable to report. So we talk about 4 different measures you can use to evaluate the performance of your portfolio or investment. The question here is which one is more relevant, more useful. So depending on the goal or objective of your evaluation, you might choose different measurements. Now, if you are going to measure the performance of the whole portfolio or entire portfolio, it's better to use the Sharpe ratio. Why? Because Sharpe ratio actually penalizes a portfolio for being undiversified. So if the portfolio is not diversified well and you are not using the right assets in your portfolio, in this case, the risk will be much higher, the standard deviation will be much higher, and the whole ratio will be much lower. And remember that the total risk in this case will be much more different than the systematic risk. And we learned that the Sharpe ratio is using the standard deviation, which measures the actually the total risk, not just the diversified or the systematic risk. So that's when we use the Sharpe ratio. However, if you are talking about the specific asset or securities or investments which you are going to add to your current portfolio, it's better to look at either Trainer ratio or Jensen's alpha. Both are very similar. However, the major difference here is that the Trainer ratio is actually standardizes returns and include the excess returns relative to beta. And for sure, both they require to estimate the beta, and you have to be careful that you should be consistent in beta calculation. So don't get your beta from different sources with different assumptions and estimation. So it's better to make sure they are consistent. We also talk about the information ratio, and I mentioned the information ratio is actually providing a better or I would say more complete picture than the Jensen's alpha because it includes the standard deviation of errors, so it provides you a better picture. That's it for today. Thank you very much. We'll talk about some major notes in the next lesson, which is our last lesson from this module, and also I will review some questions. Till then, thank you very much. Have a wonderful day. Take care. Here is Ali Talabi. Talk to you soon. Bye.